Okay, we're now going to talk about question 7. And so this question says, it's a linked list question, and it basically first starts by defining a linked list node class. And so this is called link. And we see it's pretty standard, right? It has a head and a tail. And the only thing that's a little special that it warns about is that the head is just a final value, so it can't be changed. Other than that, though, it's a pretty standard linked list implementation with the head and the tail. And so the following method performs a step used in, for example, bubble sort. And so we just want to fill in a method to basically meet the spec in the comment here. And we don't want to create any new links. So in other words, we're doing this destructively, and we're going to modify the links passed in. So the comment says, this method bubble exchanges adjacent elements of the list starting at L, in which the value in the first is larger than that of the next. So in other words, we're starting at the beginning of the linked list, and we're going to swap when I'm bigger than my neighbor, or the bigger than the element after me. And it's going to perform this in a particular sequence. Specifically, it exchanges the first and second items if needed, and then the second and third of the resulting list. For example, if A initially contains the sequence 381692, then after calling bubble, it's going to look like 316829, and it will return the resulting list. And again, it's destructive, so it creates no new links. And so I think before we even start trying to write any code, we should make sure we understand the problem. And so I actually have a separate sort of scratch sheet here where we can work and see an example of us bubbling. And so what happens? Well, initially, we're going to look at the 0 element, and we're going to say, hey, if I am bigger than my neighbor, we should swap. But we're not, so we keep going. We say, hey, if I'm bigger than my neighbor, we should swap. And they are. So we swap these two. Oops. Oh my goodness. Hello? Oh, okay. I'm having problems, guys. Okay. We swap these two. And then this element's tail is now, we're going to bubble the rest of it. And so we look at the next index. Even though we've already seen 8, we're just looking at the next index, which 8 happened to move to. And so now we ask the same question again, which is, hey, should I swap with my neighbor? And we should. So we swap. And then we move on to the next index. And we say, hey, should I swap with my neighbor? But we shouldn't, because 8 is smaller than 9. And then we ask one more time, and here we should swap with our neighbor. And then we move on to that final element. And we actually see that 9 doesn't even have a neighbor, right? Its tail is null. And so we're done. And we see this aligns with the example given earlier. And so this is how bubble is supposed to work. And now that we are all on the same page of this is how bubble works, we can actually start trying to fill it in the skeleton. And so let me put this over here. Okay, cool. And this is our example that we'll work with as we're writing this. So looking at the skeleton, we can assume that this is going to be a recursive method, right? Things with linked lists often tend to have some sort of like recursion or iteration. And we see that there's no structure set up right now for iteration, right? There's no for loop or while loop. So we can assume we're going recursive here, which means this is probably our recursive base case. And just taking another leap of faith, because we know that we start by passing in the beginning, we can assume that this base case is probably going to be when we reach the end, right? Because as we saw, when we reached the end of the list and 9 had no neighbor, we had to stop. And so it's probably going to be some sort of null check, maybe something like if L.tail equals null, right? Or something like that. And oops, I'll put a question mark since we're not sure about this, but this is something that, knowing nothing about the rest of the problem or the skeleton, I could fill this in and probably get a point on an exam. Cool. So that's just my gut instinct because we know that we're going recursive and we saw that we had to stop earlier when we had no neighbor to compare to. Okay, cool. Then we have this if statement. And there are two options basically for the behavior. And so we're not exactly sure what should go here. But thinking about how I approached this problem as I was walking through it with you guys, right? I started at this node and I said, hey, are you bigger than your neighbor? If you are, you guys should swap places. If not, just bubble on the rest of the list. Then we asked it again. Hey, are you bigger than your neighbor? If you are, you should swap places. And if you're not, bubble on the rest of the list. And so we saw the question we kept asking is, hey, are you bigger than your neighbor? If you are, let's do one behavior. Else, let's do another behavior. And so that probably is a big hint for what we want to do in this if statement. And we see that there's one option with 4 lines and another option with 2 lines. We can assume that the option where you are bigger than your neighbor and you have to swap probably takes more work and more code than the case where you're not bigger than your neighbor and you don't need to swap, right? Doing something probably takes more lines of code than doing nothing. And so we can assume this is going to be the swap case where you're bigger than your neighbor, and this is going to be the no swap case. So if L.head is greater than L.tail.head, if I'm bigger than my neighbor, then I'm going to do some sort of swapping. Else, I'll do something else. And so now I'm not exactly sure how to proceed, right? But I'll just work through my example and see how far this takes me and see what needs to be done in code. We know that in our example, we pass in the start of the linked list, and the end result of the thing we should return is going to be the start of the final linked list, right? And so looking at our example, if we start by passing in L points to 3, in this case, what needs to happen? Well, we don't need to swap, right? So we're in this case, but I do need to bubble the rest of my list, right? I need to recursively bubble on the tail. And then at the end of the day, what do I need to return? L, right? Because I need to return the pointer to the start of the list. And so based off this, I'm going to say we return L, and also we need to recursively bubble my tail. And so we're going to say L.tail equals bubble of L.tail. Cool. Let's just see how this works, right? If what I do next is a recursive call to bubble on my tail, and that's what 3's tail is going to be set to, then what happens? Well, now we've entered the case where L.head is greater than L.tail.head, right? 8 is greater than 1. And so we've entered the swap case. The skeleton already defines for us, hey, you're going to make a new linked list pointer called second, and that's going to point to L.tail. So second points here. Now, what needs to happen? Well, according to the spec of the problem and what we were doing earlier, we need 1 and 8 to swap, right? So it goes 3, 1, 8, 6, 9, 2. But the other thing is that, remember, when we were bubbling, we started at this index, then we bubbled here, and then we had to still bubble everything beyond this, right? So we need to make sure that there is a recursive call to bubble that basically starts at L, right? Because L is the 8 element, and we need this whole thing to now get bubbled because we're going index by index basically in the linked list. And so we need to do the next spot. Okay. So in other words, what needs to happen? Well, I need to get this whole thing in order, and then I'm going to recursively bubble that. So basically, L's tail needs to jump to point to second's tail, right? This is sort of the first step of our swapping. And so once we do this, we'll look something like this. Okay, so L.tail equals second.tail. And what does second's tail need to point to? Well, second's tail should be before here, right? Pointing to L. But should it just point to L? Or do we need to make, like I said, that recursive bubble call, right? So second dot tail is going to be bubble of L. And so what this did for us is that, oops, sort of rearranging here, we see second dot tail is now going to point to the result of recursively bubbling all of this, which is what we wanted. Great. Okay, we're so close. Sorry, I'm trying to rearrange. It's so messy. Ay, 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 ay. Okay, so 8 was pointing to what second tail was. Now we see second is going to point to the result of recursively bubbling all of this stuff. And the last thing is, what do we return? Also in my image, we haven't, what we were defining right here, right? Whatever gets returned from this recursive call is going to get passed back up to 3, right? Because we said 3's tail, or L dot tail, is going to be set to the result of recursively bubbling everything else. So then what do we want to return? Well, we want to return the head of the new linked list that we had just bubbled, right? And so if what we want to return is the front of the new list, as far as this recursive call went, second should come before L, right? We agree that we entered the swap case because second should be the new first, which means second is the front. And so what we should return is second. Woohoo! And now we filled in all the lines of code. And so I think the one thing that still had the question mark was that recursive base case. And so let's just check this out and maybe make sure everything makes sense. We see that we're going to keep going and keep going. And we do some more swaps along the way, right? 8 gets swapped with 6. Oops. 8 doesn't swap with 9. We're at 9 and we do swap with 2, right? We return second, and then we recursively call on 9. And when we see 9's tail is null, or in other words, there's no neighbor to compare it to, we're avoiding this null pointer, then we're going to return. So we should be good. And this is the solution to the problem. And I hope you had fun doing it.